this, and you'll get a copy of this recording, everything you hear and see on the desktop. Now, if you want to minimize that control panel, click on that orange square again. That's like a toggle switch. It opens up your desktop so you can see more of it, but it still leaves it active. Okay?
Okay.
All right, hold on. All right, let's see. We only got about 20 minutes. Let's get started right off the get-go with parallel lines and transversals. Now, I understand that you're not going to know most of this stuff at this point, so let's start off with what happens when you have two parallel lines. You know what parallel means, right?
Mm-hmm.
Okay. And a transversal. The most important thing to remember about this is that you create only two unique angles when you do that. This is the same as 1, this is the same as 2, this is the same as 2, this is the same as 1, this is the same as 1, this is the same as 2.
Okay.
So when you have a transversal and two parallel lines, there's not a lot really to figure out. Any acute angle is one of them, any obtuse angle is the other one. And more importantly, 1 plus 2 equals 180 degrees. Okay? In other words, whenever you have a straight line like that, these two angles, A and B, are always supplementary, meaning they add to 180 degrees. Okay? If you have a question or aren't understanding something that I'm saying, please say something. Don't let me just go right on. I never want to go forward until you understand what we've covered. So in this picture, we have two parallel lines, M and N. We have a transversal. What's the measurement of X?
130?
140.
Okay.
In other words, I think you knew that they had to add to 180. You just did the math wrong. But in other words, the 40-degree angle is this one down here. The angle they're asking about is this one up here. Well, the one thing we know is that that's the obtuse angle, that's an acute angle, and they have to add to 180.
Yeah, I forgot the 40 there for a second.
Okay. All right. This one is an isosceles triangle. The definition of an isosceles triangle is it has two sides that are the same. And you generally designate that with little tick marks like that. In other words, this says that side AB is equal to side BC. That's all. Okay? And furthermore, they're telling us that this angle is 50 degrees. The other thing about isosceles triangles is that not only do they have two sides that are equal, but the opposite angles are equal. In other words, the angle that's opposite to side AB is this angle C, and the angle that's opposite side BC is this angle A, and so I can say that angle A has to equal angle C. Furthermore, what's the sum of the angles of a triangle equal?
180.
All three of them are equal to 180. So what is side A? What is angle A or angle C? If they're equal and they add to 180. I mean, if all three of them add to 180.
75.
Well, 65. In other words, we have 50 degrees plus x has to equal 180. So we have 2x has to equal 130. X equals 65. Okay? Now, you're going to find that geometry has as much algebra as geometry. In other words, almost all geometry problems, you need to use algebra to solve them. This is totally algebraic down here. But we needed to know that the sum of all of the angles in a triangle equals 180 in order to formulate that. Okay, so I know that that angle is 65. The angle they're asking about is that one. What's that?
65.
Remember when you have a straight line and you have another line intersecting it? These two angles are supplementary, meaning they add to 180.
$115?
180 is like a magic number in geometry. If you want to get good at something, be able to subtract numbers from 180, because you're going to be doing it for the next year at least. Seriously. Because mainly because of two things. Because of that, those two have to add to 180, and because of this. The sum of the angles of a triangle have to add to 180. Those two things means you're just forever figuring out what the other side of 180 is. In other words, what 180 minus 65 is. So there's a little bit of a trick to that, which we'll get to later, but we won't worry about it now. Now, these problems that I have here are really the basic geometry problems that you need to get out of geometry class knowing this stuff. And that's all I'll say about it at the moment. But all right, let's have a look at this. You know what a right angle is? It's 90 degrees. It's where two lines are perpendicular. They want to know the area of ACD, this triangle right here. What's the general formula for the area of a triangle?
A squared.
1/2 base times height. Okay, memorize that one. That's huge. Okay, it's almost like, well, you probably don't know the area of the circle either. I have to keep telling myself that you haven't probably had much geometry at this point. But you may have had a little bit. They must give you some of this before you take geometry class. But anyway, the base is clearly that dB. In this case, the base is going to be DC, because they're talking about this triangle here. More importantly, the height is the vertical height. So, what's the area of triangle ABD? What's the base?
8.
What's the height?
4.
So that area is 16, the whole thing.
Mm-hmm.
What's the area of just this triangle?
10.
Yeah, in other words, it's the vertical height that matters, not this lateral height.
Mm-hmm.
All right, similar triangles. You know what they are?
Two triangles that are similar in shape but different in size.
Yeah, pretty much. And what that means is they have the same three angles. Okay, in other words, you have similarity when this angle here is the same as this angle here. In other words, I could do like this. This angle here is the same as this angle here. And finally, this angle here is the same as this angle here. And that's what these marks mean. If you see an angle that has one hash, one tick mark, that means it's the same as that. The thing about similar triangles is the proportion of their sides is the same. In other words, in our picture here, the small one has a side of 3 there, the big one has a side of 6. That gives you a similarity ratio of 1 to 2 or 2 to 1, depending on which way you're looking at it. Well, that ratio is the same for every side of that triangle. In other words, they're saying if this is 8, what must this be over here?
4.
And if this is 7, what's this one?
14. No. 3.5. Sorry.
3.5. And that's true with all similar triangles, whether they're oriented the same or not. In other words, here's a right triangle that I'm going to make dimensions 3, 4, 5. And here's another right triangle. And I can say those are similar. Okay? And if they're similar, and that's 6, meaning this one's also a right angle, and this angle here is the same as this angle over here, whereas this smaller angle here is the same as this smaller angle there. So the difficulty a lot of times with similar triangles is recognizing which angle is the same, because they don't always come aligned perfectly like this. Sometimes they'll come like this, and you'll just be able to see what's the smallest angle. Well, then you go over to the other one, and that's the smallest angle, so that's the similarity. All right. Let's go on to the next page. It's probably strange to learn a new subject starting right off with problems, but I kind of think that's the best way to learn it. Let's take the Pythagorean Theorem.
A squared plus B squared equals C squared.
It only applies to right triangles, and C is the hypotenuse, and C is always opposite the right angle. First of all, do you get how I figure out which side is opposite an angle? What side is opposite that angle right there?
B.
Just go to the extension of the two lines that make up the angle, and that's the side that's opposite.
Right.
And if that is a right triangle, then C squared is equal to A squared plus B squared, which makes C equal to what? How would I solve that algebraically?
Square root both sides.
Correct. So it's the square root of A squared plus B squared. Now,
Just be A plus B.
no, not at all. That's a different number than the square root of A squared plus B squared. Now, the square root of A squared plus the square root of B squared is not what this equals. If it was the square root of A squared times B squared, then you could say that it's the square root of A squared times the square root of B squared. But when you're adding it, it's not going to be that. So in this case, A is 1 and B is 2. So what is C? It's the square root of a squared plus b squared. Do it one piece at a time. In other words, it's the square root of 1 squared plus 2 squared. What's 1 squared plus 2 squared?
5.
So the answer is the square root of 5. And notice that's not the same as the square root of 1 plus the square root of 2. And this is, you always want to memorize that and know that you know that, the Pythagorean Theorem. But you're going to have to solve so many right triangles over the next few years that it's worth knowing what C is and memorizing that. Normally, I'm not in favor of memorizing stuff that you can figure out algebraically, because you don't want to clutter up your memory with stuff that you can solve for. And you can always solve for C by just, if you know the Pythagorean Theorem, then you can solve for C. The thing is that you're going to have to solve so many triangles that it's worth knowing what C is, and it's worth knowing the other situation is where they give you C and they give you one of the short sides and you have to solve for the other short side. So those are the two problems that you're going to have to repeatedly do. All right. All right, let's see. This one says AC is perpendicular to BD. The measure of this is 30. The measure of that's 45. And the measure of that's 6. So basically everything they tell you in the problem is you can see in the picture. And they want to know how long AB is. Well, it's time to talk about the two special triangles that you want to memorize. And they are a 30-60 right triangle and a 45-45 right triangle. Notice the two angles, the two small angles are always add up to 90 here, since this is 90 and the sum of all three of them have to be 180. Now, if I call this the unit triangles, I call it that because opposite the smallest side is 1. Those are the dimensions of these two special triangles. Now, when I say special, I mean special. You're going to be dealing with these triangles for 3 years, maybe 4 years. These two specific triangles, all the way through trigonometry. Okay? And the purpose of memorizing the dimensions is that if I have another triangle that's similar to, say, my 30-60, in other words, is all I need is another right triangle that's like that, and I tell you this side is 4, what's this side got to be? Compare the hypotenuse of one with the hypotenuse of the other. What's the ratio? Four divided by 2.
Okay. 2.
That's the similarity ratio. The similarity ratio is going to be the ratio of each proportional side to the other. So if my similarity ratio is 2, what does that side have to be?
2?
It's got to be twice as big as this one. What's this side have to be?
2 times the square root of 3.
You got it. That's why you want to memorize these dimensions, because you're constantly being faced with similar triangles with different dimensions. Notice this problem. We know that's a 30 degree, we know that's 90, and that's 6. What's the similarity ratio with this triangle?
3.
which makes the vertical height AC equal to what?
3.
Okay. Now that we know AC is 3, let's look at this 45, 45. In other words, we also know this angle's 90 degrees, right?
Mm-hmm.
Well, if that's a 45, 45 right triangle, and this side is 3, they want to know what the hypotenuse is. What's the similarity ratio with this triangle compared to my unit triangle?
3 and 3.
Okay, which makes the hypotenuse what?
3.
3 times this number here.
Oh, okay.
Okay, in other words, everything about this triangle has to be 3 times that. Here, let me redraw it. We have a similar triangle that's 45, 45, and we only know that side. But the fact that we know that side's 3 compared to that of 1, well, that means this is 3, and this hypotenuse here has to be 3 times that hypotenuse. So that is 3 root 2. And there is a typical geometry problem in the sense that you can't solve for this side directly. But what we can do is solve this triangle to get this side here, and then once we have that side, we can use the similarities and the unit triangles to get AB. Okay? All right. Let's stop there. These half-hour sessions you're going to find a lot more palatable than hour-long sessions. Just because it's much easier to focus for 30 minutes than it is for an hour. All right, let's see. Do I have your email address, which I'm going to need to send you this link, a copy of this link. Why don't you give it to me?
CROLL.
CROLO. CROLO?
LL. 2 L's.
CROLLO?
Mm-hmm. No L. No O after that. No O after that.
Okay. CROLL.
White 3.
Okay.
At iCloud.com.
At what?
iCloud.com.
iCloud, okay. And there was an R after the C?
Yeah, there was an R after the C.
Okay. So CROLL white 3 at iCloud.com.
Yep.
I will send you a copy of this. It takes a few hours to process, but I'll send you a link to how you review this recording if you like. And you might find that useful. You might not. Doesn't matter. You can use it as you wish. But it'll probably be more helpful to you once you get into geometry class and you're taking tests and stuff. You might be more interested in reviewing our tutoring sessions. So, all right. Well, that's the way it works. You can see that it works pretty similar to being in person. There shouldn't be a whole lot of difference. All right. And I'm going to stop